Problem solving in data, lesson 2 is about ratios and proportions. This covers primarily standards 1 and 3. And let's first start by defining what a ratio is. This is a comparison of two values. And it basically says how much of one thing there is compared to another thing. So like basically what is the ratio of boys to girls, right? There's so many boys to so many girls, and it's just comparing the difference in numbers. Now, next, always read when you're asked, what is the ratio of blah, 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 always read the order they are asking you to set the ratio up in. That is critical because the order does matter. Now, once we know what ratios are, then we can talk about a proportion. And a proportion is basically a statement that sets two ratios equal. Now, whenever you set up a proportion, it is always important to keep the order of the ratios the same when you're setting this proportion up. And then once we go to solve a proportion, right, you basically cross multiply and then solve the equation. So all of these problems use ratios or proportions in some way or another. Some are easy, some are hard, but you have to pay attention to small little details. Okay, let's get to it. So the first one says to make a bakery signature chocolate muffin, a baker needs 2.5 ounces, right, of chocolate for each muffin, for one muffin. Now it says how many pounds of chocolate are needed to make 46 signature chocolate muffins. So not only do you have to find the number of pounds, but you have to remember they give you this problem in ounces. So we know first what we're going to do is we're going to say 2.5 ounces for one muffin equals how many ounces for 48 muffins. When I go ahead and set this proportion up, remember, number of ounces, number of muffins, right? So when I set this up and now I cross multiply, x equals 2.5 times 48 would give you 120. Now, that means you would need 120 ounces, right, of chocolate to make the 48 muffins. But the question is asking how many pounds. So we're going to take the number of ounces and divide it by 16. 120 divided by 16 would give you 7.5 pounds of chocolate, letter A. Okay, the next one. In the 1908 Olympic Games, the Olympic marathon was lengthened from 40 to approximately 42 kilometers. Of the following, which is the closest to the increase in distance of the Olympic marathon in miles? So here's the thing. We went from 40 to 42 kilometers, meaning we increased 2 kilometers. So the question is basically asking how many miles is 2 kilometers. Now, anytime we go to do these conversions, I'm basically going to start with what I have, 2 kilometers times. Now I'm going to use this conversion, 1 mile to 1.6 kilometers. And remember, when we do this, we want kilometers to end up on top to cancel out to leave us with miles. So we're going to go 2 kilometers times 1 mile per 1.6 kilometers. So that now, technically, if I put this over 1, when I multiply across the top, I get 2 miles over 1.6. And remember, the kilometers cancel out here. And when I do 2 divided by 1.6, I end up getting 1.25 miles. Letter B. Okay. Now the next one. This is a calculator problem and grid response. Horsepower and watts are units of measure of power. They are directly proportional such that 5 horsepower is equal to 3,730 watts. How much power in watts is equal to 2 horsepower? Well, here's the thing. When you set this proportion up, keep the order the same. You know you have 2 horsepower, so that goes in a numerator to match up here, is equal to how many watts? Okay, and I'll use W for watts. So now when I cross multiply, 5W, right, equals 3730 times 2. 3730 times 2 would get you 7,460. And when I divide by 5, W would be equal 1,492 watts. And it's a gridded response, so you would bubble that in. So in the next example, a quality control manager at a factory selects 5 light bulbs at random for inspection out of 400. So 7 inspected out of every 400 light bulbs. At this rate, how many light bulbs will be inspected? I don't know the number inspected, right? If the factory produces 20,000 light bulbs. So if I look here, my numerator represents the number of light bulbs inspected. My denominator represents the total number of light bulbs. That's keeping the order the same. So now when I cross multiply here, 400I equals 7 times 20,000 is 140,000. When I take 140,000 and I divide it by 400, right? You get 350. So 350 light bulbs would be inspected. All right. Next one is a 2-part question. All right. The amount of money a performer earns is directly proportional to the number of people attending the performance. The performer earns $120 for every 8 people that attend. How much money will the performer earn when 20 people attend the performance? So I'm going to do $120 to 8 people equals how much money for 20 people? When I cross multiply and solve this, 8M equals 120 times 2 is 240. And when I divide by 8, right, the amount of money would be $300, letter C. So now the second part of this question says the performer uses 43% of the money earned to pay the costs involved in putting on the performance. The rest of the money earned is the performer's profit. What is the profit the performer makes at a performance where 8 people attended? So when you have 8 people, you have to remember, and that's the tricky part, you make $120. Now, if 43% go to cost, what percent is for the profit? Well, 100 minus 43 is 57% goes to profit. So the profit, easiest way to figure it out would be 57% is 0.57 times 120, and 0.57 times 120 would give you $68.40, letter C. The other way to do it would be to do 0.43 times 120 and then subtract it to get the difference. So right away here, the table above represents the 50 movies that had the greatest ticket sales in 2012, categorized by movie type and Motion Picture Association of America rating. What proportion of the movies are comedies? So we have comedies, right, with a rating of PG. 13, sorry. So, 4 movies were comedies with a PG rating of PG-13. That's 4 out of how many? 50 total movies. Therefore, when I look, 4 out of 50 is not an option here. So what can I do with this fraction? Reduce it by dividing by 2. You would get 2 over 25, which is letter A. Now the next one is a two-part question too. 3 colonies of insects, right, were treated with the different pesticides over an 8-week period to test the effectiveness of the 3 pesticides. Colony A, B, and C were treated with pesticides A, B, and C respectively. Each pesticide was applied every 2 weeks to one of the 3 colonies over an 8-week period. The bar graph above shows the insect counts for each of the 3 colonies, 0, 2, 4, 6, and 8 weeks after the initial treatment. So the first question says, which of the following colonies showed a decrease in size every 2 weeks after the initial treatment? So your initial treatment was here. So when I look at colony A, from here to here to here, each week, every 2 weeks, it decreased. So A works. B went down, went down, went down, went down. That worked. But if I look at C from 0 to 2 weeks actually went up, so that didn't work. So right away when I look here, it would only be 1 and 2. The next question says, which of the following, which is the closest to the ratio of the total number of insects in all 3 colonies in week 8 to the total number of insects at the time of the initial treatment? So basically you have to understand, we have to put it in week 8 to the initial. So week 8 to the initial. So how many insects did all 3 add up to in week 8? So this, I'm going to say, is approximately 20. This is approximately 10. And this is approximately 50. So that would be 20, 30, about 80. So my numerator here would be 80 over. Now, the initial treatment, I would say this is 80. This is about, say, 65. And that's 40, that'd be 50. So I'm going to say that's about 55. When I add these up, that's 80 plus 65 is 145. Plus 55 is about 200 at initial treatment. Now, when I look at this ratio, 80 over 200, both of these can be divided by, just start with, if I look, I'm just going to go to my calculator, 80 divided by 200, right? I would get a decimal 0.4, but if I hit math, enter, it would give me a ratio of about 2 to 5, letter A. Okay, go ahead and try the assessment problems and let us know if you have questions.